I think we'll really like this problem. It looks a little intimidating at first, just with all the notation and stuff like that, but that's just your first derivative, there's your second derivative, gives us an initial condition, initial point, 1 comma 2. And everything here we've been practicing, we can get everything, every single part of this problem right here. This stuff at the bottom, this estimate less than that, I think we've seen that before, but we haven't seen a lot of it. So let's just rock this thing, right? Write the equation with a tangent line. You got the x is equal to 1, and we know when x equals 1, the y value is equal to 2. So I got the point, and then for the slope, you got to plug that point in place for x and y into that first derivative right there. So I just went to that first derivative, plugged in the 1 and the 2 for the x and the y, got 8 for the slope, and I did my point slope form. Boom, there's the equation of the tangent line. Letter B, we're supposed to use that tangent line to approximate f of 1.1. So you could plug in 1.1 right away and then move the 2 over. Usually when I need to use it for something, I like to just solve that for the y right away, and then I'll plug in that 1.1 for the x and get this 2.8 number. Now, anytime they have you use a tangent line to approximate something and then turn right around and ask, is that approximation, is that estimate greater than or less than the actual y value? What they're meaning for you to do is look at your second derivative, okay? And I'll explain why in a second. But for now, let's just take this point 1 comma 2 and plug it in for x and y into that second derivative there. And you can see all my work there. Be careful with your arithmetic. It doesn't matter what the number is. You're just concerned whether it's a positive number or a negative number. So I got 8 times 13. Yeah, I could have multiplied it out, but it was a no calculator part there. I didn't care about it. I just knew that was going to be a positive number. And so the reason the estimate is less, all right, if your second derivative is positive, that means your original curve will be concave up, right? And so if you have a curve that's concave up, all the tangent lines that you draw, like if that's your point right there and you draw a tangent line and the curve is going up, then all the tangent lines are going to be below your actual curve. So like the point that you're finding, this 2.8, is on your actual tangent line, which is like right here, but the point on your actual curve is up there because the curve is concave up. So I think that's like in your blue packet someplace there. We've seen that a couple times there. And the reverse is true. If your curve is concave down, then all the tangent lines you draw are going to be above there. And then so that's why that estimate is going to be less, since the second derivative is positive. But that's what they want to hear. So I think everything else about this problem we've seen a bunch of before, but if we could study the little things like that, and then, you know, that could be a little concept that separates us from the rest of the nation if other people aren't struggling those or seeing those as much. All right, and then letter C says find the particular solution. So when it tells us to find it, this is where we're going to start with that first derivative. We're going to integrate both sides. Remember to plus C. Separate your variables first. Get the y's with the dy, x's with the dx. Then integrate both sides. Remember to plus C. Use the point that they gave you to plug it in, figure out what that C value is, and then solve that equation for the y. So this is all my work for letter C right there. I started with that first derivative, multiply both sides by the dx, divided by the y cubed to get the y's with the dy, x's with the dx. And then remember, when you integrate this, it's not an ln just because you see 1 over something. It's 1 over y. It's not 1 over a single letter. That's y to the -3. So you integrate that, you're going to go y to the -2 divided by -2. Get rid of those negative exponents there. That's as easy, x squared over 2. Remember to plus C right away. And then right away, take that point that they give us, plug the 2 in for the y, plug the 1 in for the x, solve that. You can see my arithmetic there. Be careful with that without the calculator. You're going to get your C value right away. That's your concept of integration. And then once you find that, plop that back in. And then now I'm over here, we're supposed to solve it for the y because it says y equals f of x. So solve this for the y. Not the only way you could have solved this. You might have taken a slightly different approach, multiplied everything by the y squared and whatever. But typically, if I got the y squared on the bottom, I'm going to need to get it out of that denominator. And if I got a couple fractions over here, it's helpful to get one fraction. So then I could just cross multiply. So just kind of keep that in mind if it looks a little bit funky. But that's all I did. I got a common denominator. So I put a 4 here and a 4 there. Got a common denominator, one single fraction. And once you have a fraction equals a fraction, I just cross multiplied. Get y squared is equal to something. Not a necessary step, but I -8 divided by 2, it was a -4. I could have left it like that, but since I was about to square root both sides, I took the negative and I stuck it on the bottom and distributed it, and that's why it became that. Not a necessary step, but I just thought it might look a little bit nicer underneath the radical. But then you're just going to square root both sides. Now, when you square root both sides, there is going to be a plus or minus, but you need to choose whether you're going to use the positive one or the negative one. You don't just stick the plus or minus right there. The way you choose is you always look at the initial condition. That's why I got this little 2 underlined. You're trying to figure out whether the y is a positive or negative answer. And since that initial condition, the y is a positive number, that's when I'm going to choose that positive answer right there. So I'm thinking we could have left it like this, but I knew the square root of 4 was equal to 2 there. But make sure whenever you choose a plus or minus, you look at that y coordinate, you look at what that is. Is it a positive number or a negative number? That's how you choose that plus or minus. So it's a pretty easy part of the problem there. So just let's practice those. Let's be perfect with every single part of that. Ice skating. I ain't never been ice skating. I want to go sometime.